Hey there, welcome back to another video of our network automation video series by PyNet Labs. And as you have been watching previous videos, we have talked about and we have also implemented multiple type of automation in normal devices, be it catalyst switches, be it routers, or I would say be it some other devices. And you can use transport protocols like SSH that we have been discussing rigorously, and you can use transport protocols like telnet as well, and both of these protocols can actually be used on devices as a part of minimum configuration, be it all these three devices that we just saw the lab of in the previous video. And you can deploy automation by actually getting connected with the physical machine that we can actually call it as management PC. And on this management PC we have been installing Python, and we have been installing various other kind of softwares, be it an IDE, which can be VS Code that we actually saw how we can work with. And by using or by building a Python script, we have deployed all these configuration onto various devices, okay, be it this device, be it this device, be it this device. And the protocols that we have been using as a transport one are SSH and Telnet so far. But this is not how usually all the devices gets configured into the production environment, because in production environment the devices would be of high scale. The product in the production environment will not really function with normal iOS or Catalyst devices that you can have. So for the same, the protocols that we need to use in order to implement automation also needs to be of a higher standard, okay. And that's exactly where model driven programmability or something like model driven programmability comes up. So when we actually discuss about model driven programmability, okay, or we can address it as something like model driven programmability as MDP. So when we discuss about model driven programmability, then you can say that the devices that we are looking forward to cater are based on different platforms of Cisco or even other vendors as well. But let's say if we consider Cisco's platform, then the devices that we are looking forward to automate can be based on the iOS XE platform, which means let's say a device can be ISR series router, or it can be a CSR 1000V. If we say so, physical devices, you can have ISR or ASR series routers, or you can have virtual plans like CSR 1000V, or you can talk about implementing automation on devices that are based on the platform of NXOS. So put that. But yeah, you can think of devices that actually works on NXOS, okay, or you can talk about devices that works on iOS XR platform. Make sense? So these are, I would say, type of the platform that we talk about, okay. And these can be Nexus switches again, which largely gets deployed into data center environments, and these are again can be ISR or ASR series devices, okay, or even the virtual device that can be iOS XRV, and this can also be NXOSV. So as part of the virtualization game, or as part of advanced services like VNF and others are being deployed strongly into the production environment, Cisco has came up with different virtual images that you can install into your VMware ESXi server, and then you can make use of these virtual images inside your production as well. So when we talk about automating all these devices, we cannot really go ahead and use I would say SSH, or I would say Telnet, as part of your uh, transport protocol. So when we say that what all can be the protocols that we can use, then there comes model driven programmability. So model driven programmability offers two protocols, okay. One, it offers a protocol that goes with the name of NetConf, and many of you might have heard about it as well. And the second one is RESTCONF. Okay, one is NetConf and the other one is RESTCONF there. So, and these things or both of these protocols works in conjunction with a data modeling language which we call it as Yang data modeling. Okay, so in today's video we are just going to understand how NetConf works, how RESTConf works, and how Yang data modeling actually works here. Okay, so let me clear some things up, and we'll be looking at how you can actually automate all of these platforms that are available here, as well as MDP or Model Driven Programmability can be implemented against XC, XR, and NXOS, all these three platforms for Cisco. So if I give you a glimpse about how NetConf, RESTConf, and Yang data model came up into existence, then in 2001 you can say that there was, I would say, a meeting that was actually held up, and you can consider that the meeting was actually conducted by an organization which is IETF. And IETF held this organization and they invited different vendors, be it Cisco, be it Sienna, okay, be it Juniper, or be it some other vendors, including some of the other people from Google, okay, or Amazon, or you can say Netflix even, or many other people. You can just consider that there were a group of people that were invited, and in that group of people the major motive was to have bigger production scenario handling people, so that they can give their inputs on how better you can actually think about network automation being deployed. So you can say that when we talk about it, then I would say the major approach of bringing out these protocols like NetConf and RESTConf was kind of an improvement over the standard protocol that was being used, which was SNMP. And SNMP has been there for quite a long time, and we still use it. And by bringing out network automation protocols like NetConf and RESTConf, it doesn't mean that they are going to be vanished. Like, and SNMP is not going anywhere. It is still used with many of the applications. The more approach or the more of the limitation that SNMP had, that you could only monitor the data, right? And you could not play with like not able to modify the config, okay, of different data stores, be it like running configuration or be it startup configuration. Whatever configuration that would be, this was kind of the major limitation, that by using SNMP you could not modify the configuration of the device in that optimum way that is possible. And that's exactly because SNMP is the best protocol till date as well, in order to monitor the network on a centralized location, so that you can look at all the devices that you have, and you can get the monitoring information of everything that is deployed into your production. But this is not a greatest tool that is available in order to configure the device. And as I told you, that when SDN came up, SDN was more of an approach that completely focused on something called centralized management, okay, and configuration. Okay, and how does it do that? By centrally, okay, managing the control plane. Or you can say that SDN had more of its approach towards decoupling the control plane and data plane operations. Okay, so when we talk about how these modifications I came up with in 2001, this IETF conducted a workshop was more of having to be able to implement the thought process behind SDN in replacement of the SNMP. So vendors and companies and bigger production environments needed something that they could use in order to centrally be able to being able to manage the network. And that's exactly when in 2000 and I would say 6, NetConf came up into existence. Okay, And when NetConf came out, then NetConf kind of became very popular, and it started to be used in a limited way possible, until unless this is going rapidly famous now, because this is the time when every company is actually looking forward to implement automation in their network. Special thanks to COVID. So when we talk about these protocols, let's get a glimpse of this NetConf protocol in a detailed overview then, and then we will move ahead with the next thing. Yeah, so under model driven programmability that you have, the first protocol that we have is NetConf. So you can assume that you have a device, and this device is CSR 1000V, okay, and this device is connected with a switch, okay, and that switch is again connected to the WAN network. And inside of this WAN network, there is somewhere the user which is using the management PC, under which most of the automation things or most of the automation tools that we need to configure the devices are installed. So when Cisco announced, I would say, the NetConf support, then it announced for 3 of its products. It announced for devices that are based on platform iOS XE, it announced it for iOS XR, and it also announced it for devices that works on NXOS, and that's currently the support that is available. Now usually you consider the device that you want to configure by using NetConf as NetConf server, where the NetConf feature will be started up, and you actually consider the management PC from which you will be deploying the configuration as NetConf manager, or you can call it as agent as well, because that's the agent software that you will be using. Okay, so when you have both of these as the management PC as NetConf client or manager or agent, then this PC will deploy the configuration onto the device by using a feature of model driven programmability. Now what exactly is this model driven programmability? Now, as we have been doing automation onto different devices, we were using CLI commands in order to deploy automation, right? Or we were using CLI commands to provision the device with the required configuration by using Telnet or SSH as the transfer protocol. Now, if we talk about the protocol stack that NetConf uses, then for transport purposes it still uses SSH, okay, and it uses SSH on port number 830. That's what NetConf uses. It doesn't use the standard SSH port number, it uses by default port number 830. So upon creating or upon enabling NetConf server onto the device, the management PC will actually try and connect with SSH port number 830 onto the device, and then if authentication is successfully done, then the connectivity between the management PC and the CSR router from our topology will be established. Then in order to parse the data, the normal devices that we were using, for example, if you have a catalyst switch, let's say R1, and then that R1 is connected with management PC, then you would directly send CLI commands, correct? And these CLI commands will be considered as data that we send onto the device. But over here, the data, meaning the type of configuration that we use, isn't sent into like the normal CLI form. The data needs to be in a structured form, meaning that you will be using data structuring languages that would be JSON or that would be XML. Now this JSON or XML gets used as part of the model driven programmability, but the only protocol that I would say NetConf support is XML itself. So we'll be using XML in order to build up the configuration of the device. Okay, then there are different operations that are supported by NetConf. So there are three type of operations that NetConf supports, and if we talk about those operations, then the first operation that NetConf support is get. The second operation that the NetConf support is get config, which is and the third operation that NetConf support is edit config. Makes sense? These are three type of operations that your NetConf protocol actually supports. Now, in order to understand what this get config and edit config is, you also need to understand different data stores that are available on all these three platforms. Okay, so there are three type of data stores that exist in today's networking devices. Okay, and the data types, data stores, and the data that the data store contains. So one of the data store that you have is a running configuration, which we generally have in almost every device that we have. Okay, the second data store that you have is startup config, meaning that whatever configuration that you configure onto the device, that is actually live from the running configuration, which is RAM of your device. And if you want to save that configuration, you copy the running configuration into startup configuration, and upon next restart, the startup configuration will be loaded with as the default configuration of that device. Make sense? And then the third configuration that you have is candidate configuration, which has started to come as the new type of data store into the device. So the candidate configuration is the temporary configuration that the device maintains once you enter the CLI commands, and then upon committing or saving the change, it goes into running configuration, and then it gets live onto the device there. And if you want to save it, then from running you send it to startup config. So these are three type of data stores that you have. Okay, now the data is also divided into two parts. So if I show you how the data is divided, then there are two type of data. One, you have operational data, and second, you have configurational data. You have operational data and you have configurational data. Now what is this operational and configurational data? So if you fetch out a configuration of certain, I would say, interface, let's say you run a command that says show interface fa0/0, what all are going to be the outputs for you? The output specifically will be something like, it will show you the name of that particular interface, it will show the IP address that is configured, it will show you the bandwidth that has been configured, it will show you the speed that has been configured, it will show you the duplex settings that are available, it will show you the MTU settings that are available, and every other configurational parameter. And then on the other end, you can also have details that would look like the number of packets in. So the number of packets in, the number of packets out that has been traveling out of that interface, the number of packets that has been dropped. You would see delay, okay, you would say jitter, you would say some value as runs, and there would be other statistical information that can be shown up as the output of this device. So this is exactly how the two of the data types are divided, meaning there can be some configuration that can be configured onto the device, and that type of configuration is part of the configurational data. And there can be other sort of configuration which is built up as statistical information, and that type of config is operational data. So coming back to all the operations that you can perform inside the NetConf, get config and edit config. When you actually perform get operation, then you are requesting to the resource to fetch out operational data from the device. It means the information that cannot be configured onto the device and that can be built up on analyzing the traffic flow of that particular device. When you execute getConfig operation, it means that you want to fetch out configurational data from the device, which is the second type of data, which is this. Okay, and each of the data store can maintain both type of the data, operational and configuration. So whenever you execute a request from the management PC to the CSR or to the NetConf server, you can request configurational data or operational data from running, startup and candidate config. Okay, and that actually depends which type of data that you want on whether you execute get operation or whether you execute get config operation. And then the third operation is edit config, which can directly be targeted to running or startup or candidate config based on whether your device supports candidate config or not. Okay, but this edit config feature is used in order to deploy the configuration onto the device. So this is how NetConf actually works, by using transport protocol as SSH and by using data as your XML, and the targets, or you can say data stores that it uses, can be running, startup or candidate config, and the operational data, the data can be either operational data or config data. Make sense? This is the overview of how NetConf actually works and what all are the operations that are supported into NetConf protocol. Make sense? Now we will see how edit configuration, get configuration and get and works, and what all will be the data that you will actually see as a part of the XML, and why do we use XML. Okay, so when I told you that NetConf allows you to perform multiple type of operations, and those operations were get operation, that operation was get config operation, and the third operation was edit config operation. Make sense? And all these operations can be performed either on running configuration or either on you can say startup configuration, or it can be executed on candidate configuration. Make sense? Now when we talk about the parsing languages or data structuring language, that it only supports like it can execute config data, and it can also fetch out operational data. And the data that will be represented is going to be XML, and the transfer protocol is going to be SSH, and the port number is going to be 830. This is like one figure in which you can understand the complete NetConf scenario. Make sense? Now talking about how this actually works. So here comes a better understanding of how model driven programmability is assumed. Okay, so when we say that there is this management PC which will be accessing like some resources like a switch or so, and then it will be connected to the router which is CSR 1kV, right? And this is actually where NetConf server is running. So you can say that the connectivity will be built based on the SSH connectivity, right? It will be SSH based connectivity with the device, and that too on the port number 830. Cool. So when your request goes up there, then be it like any type of request, be it get or get config or edit config, then there would be certain information that will be processed. Okay, and what kind of information that will be? Let's consider that the request is get config. Now this get config request is going to be in a way that you being like you are not going to use CLI in order to execute some of the operation like show IP interface brief. This is not going to be the scenario, correct? You are more likely going to execute something that would be a part of the automated workflow, meaning you might be using some application like, let's say, Python, and this Python language needs to communicate with the device on port number 830. So usually when a machine communicates with another machine, then it understands the data that is desired or that is demanded in a structured format possible. Okay, we have been using CLI for the longest amount of time now, and CLI was created in order to make user or in order to make human understand the output that will be generated from the device, because XML and some other type of structuring languages was really tough to read the data from in back in those days. But then there are different data structuring languages that have came up, which was XML, then you have JSON, then you have other languages like YAML. Okay, and we'll be exploring some of them that are available. So NetConf uses XML as the language for communicating the info, or you can say for sending the information. And when we say that CLI is used, it means that whenever Python requests some of the data from the device, be it configurational data, be it operational data, the data that will be returned to the Python script, it will be in the form of XML. Make sense? That is exactly how machine to machine communication is done. And when we talk about machine to machine communication, then this communication can be initiated automatically as well as part of the automation. Okay, but there is something that the information that you will be seeing in XML, it will be according to the rules of model driven programmability, or you can say it will be according to the rules of, I would say, MDP. And in order to understand what all are these rules, you first need to understand something called data modeling. Alright, so as I said that in order to understand how and what this XML data will be, that you either will be sending as part of the configuration, or it will be received by the device as part of the information that you are requesting towards the NetConf server, you first need to understand how data modeling actually works. Okay, now let's take a simple picture here, that what and how the data modeling actually looks like. So for example, let's say that you are filling up some data inside a web form, and this is what your web form is. And inside of this web form, you are filling up some information like name, then you are filling up some information like address, then you're filling up some information like age, and some other information, you can say weight. Okay, and all this information will be uploaded then towards an SQL server that is situated here. Now can we say that this SQL server is a backend application, and then the web form that you see is a front-end application? Correct? This is the front that a user sees, and that's the backend that the developer designs in order to store the data that will be given by the user. Now all this data that the user will be sending on to the SQL server needs to be in a specific format. Make sense? Meaning, if I say that my name is 1234567, and I say that my address is 7891011, and then I say my age is 24, and then I say my weight is 75.2, will this information be valid for the type of web form that I'm filling? It means that the name is being sent into a data type that you can say as integer, right? Then I'm sending the information of my address also as part of the integer, and then I'm sending my age as a part of the characters, or you can say a string. Okay, that's the data types that we use, right? And the information that I'm also sending about my weight is also a string there. But this is exactly not how the SQL server expects the data to be. The SQL server expects the data for the attributes that it has, which are name, right, which are address, which are age and weight, to be in a certain way or to be according to certain rules. So it wants the name to be in the form of string, right? And the minimum character that it wants for the string is between 5 to 30. And then the address also needs to be in a string format, and the address needs to be between characters 10 to 50. And the age also needs to be in a certain format, right? It needs to be, for example, as integer. And then the weight also needs to be as a data type of float. And this configuration will be done while the development of the web form there. So whenever the user doesn't enter the information into this web form according to the blueprint, then the information will be rejected by the SQL server or by the hosting server where the application or web form is being stored or validated. Make sense? Now, creating of these rules is called data modeling. Creating of these blueprints is called data modeling. And just like you can create data models for whatever information that you want to store on a front-end back-end environment, just like that, network vendors create the data models for the network device configuration in a way called Yang data modeling. Make sense? I hope you are understanding what I'm trying to say here. Yang data modeling defines and validates each type of configuration that you can deploy by using model driven programmability or by using protocol that is NetConf. You understand that? And just like that, whenever you send some configuration onto the network device or whenever you receive some configuration onto the from the network device on your device, this information will be structured by using XML but according to the rules of Yang data model. You see that? And that's how data modeling works. And because the information will be driven by the data models, we call the protocols that uses Yang data models as model driven programmability protocols. Makes sense? That's why RESTCONF and NetConf are a part of the model driven programmability environment. So that's what the picture is over here. And by using these data models, you can actually create multiple type of configurations there. So these data models also are structured in a way. Okay, if we talk about the structures of them, let me just clear some of the content that we have on the display and explain you how the data models will be structured. Yeah, so the data models will be structured in a way that every model contains a module name, and this module name is called as XML namespace information. That actually, by using this XML namespace, the device can identify which data model is this device using. Now, the data model is created by two type of organizations. Yeah, it can be created by standard organization, and that standard organization, there are two type of organizations. One is IETF and the other organization, which is also a standard, is called as OpenConfig. These are two organizations, those create standard Yang data models. And then the second type of body that you can have are vendors themselves. So vendors like Cisco, vendors like Sienna, vendors like Juniper, vendors like Huawei, Nokia and others, they can create their own data models as well that supports their devices. And all these data models will be uploaded onto the device when the upgrade is done or when a newer update of the operating system or the image is released. So for example, when Cisco CSR 1000 we launched, if we talk about 16.5, there were very limited data models that were available onto the device. And if we talk about 16.9, then there were plenty of data models that were available. So after every release, the list of data model keeps on updating, and the vendors try to upload as many data models as they can onto these devices. Make sense? So after the device uploads these information, then how is the structure of this data model that is created? Okay, by be it like a standard data model or be it a vendor neutral or vendor based data model that you have. So the information is stored in a structured way. So first you will have a module name. Inside of that module name, there can be multiple containers which kind of groups the type of configuration that can be there. So you can have a container like this, and then inside a container you will have lists of configuration. There can be IP config, there can be description, there can be name of the interface, and so on, so and so. And all these parameters are called as leaves. Okay, so you can have leaf as name of the interface, leaf as description of the interface, leaf as IP of the interface, leaf as subnet mask of the interface, leaf as whether the interface needs to be up or down as the leaf over there, and every leaf needs to have a type. You can say every leaf must have type attribute. And this type attribute defines that for the leaf, how, like what type of data should be accepted by the user. So if I say the name of the leaf is name, then I would say the type is string. If I say that the name of the leaf is enabled, which will actually identify whether the interface needs to be up or down, then I would say the type of that particular leaf needs to be Boolean value. So if I say enabled is true, I will say then that will basically be ending up configuring the device as up, having the interface up or so. So this is how the configuration is built up based on the data model. So you have a major parent, which is, I would say, oops, sorry. You have a major parent, which is actually the name of the data model that you have. Then every model has a container there. Module has a container, and the container can contain the data, be it like operational data or be it config data. And every container has a list which groups all the node configuration, and every node configuration can be addressed by leaves, where every leaf has a type attribute there. This is how the structure is created, and based on this structure you create your XML data, and we address this XML data as XML payload. So for example, if I show you how the information will be for an interface configuration, then for example, we will be using a data model, or we'll be using, I would say, some sort of interface configuration that the data for that can be written down into XML. So I'll say the name of the container that I want to use is interfaces. And then I can say that whatever namespace information that is. So I can specify the namespace of that particular data model, which is IETF interfaces inside the namespace tag. And then I can specify the name of the container of that tag. And then I would say what is the children of that particular tag will be the name of the list. Let's say the name of the list is interface. And then I will specify the leaf information. And I would say that the first leaf is name, and then I will say, for example, gigabit ethernet 1, and then I will close the name tag there. Then the second information will be description, so I'll specify whatever description that I want, and then I will close down the description tag. And then I would say whatever the enabled state needs to be, and I will say like true. So the enabled state keeps the interface or turns on the interface, equivalent to the no shutdown command. And then once I'm done stating the information, then I can say close interfaces, which is the list that groups all the configuration, and close the interfaces container as well. And this entire thing will be called as XML payload that I want to send by using SSH as my transport protocol and NetConf as my automation protocol, or model driven programmability by using this payload. And that's exactly how model driven programmability works with the help of NetConf as a protocol. So I hope you understand. It's quite complicating, I would say, at the very first go, but I request you to watch the video at least for twice or thrice and make sure you understand every part of this configuration. However, we're going to see the labs of how you actually get able to perform all these operations, be it get config or edit config. And once we get familiar with all these concepts over here, then we will be implementing the labs by using NetConf, and then we will move on to the next model driven programmability protocol, which is RESTCONF, but which is not going to be a big of a task, because once you make sure that you understand NetConf and model driven programmability, then doing RESTConf won't be a big challenge for you. So please revise this concepts, okay, at least twice, and make sure that you understand every bit of what we have discussed. I try to keep it as simple as I can, and I hope you enjoyed the content of this video. Okay, thank you so much. I'll see you guys in the next one, in which we'll be talking more about how you can do the labs, and we'll for sure implementing the lab there. So thanks for watching. I'll see you guys in the next one.